Today, he's one of the driving forces behind DevOps for Kids. He is about to run his 30th marathon, and in his spare time, he's also the principal open source technologist at Amazon Web Services. Please welcome to the stage Arun Gupta.
Thank you, Ayala. Thank you so much. All right, good morning.
Hey.
Very cool. OK. So I've known some folks behind JFrog for quite a few years, some of them far too closely, actually. So it's really a huge props in terms of what they do for the DevOps community. So it's really good in that sense. Now, let's take a look at it. What are we doing in their tagline particularly, which says release fast or die, lends itself very well to the serverless, what serverless is doing for application development. Let's take a look. On May 26, 1995, Bill Gates sent a memo to his executive staff at Microsoft. The title was The Internet Tidal Wave. And in that memo, he says, there is a scary possibility where the Internet fans are getting together. Remember, this is back in 95. The Internet fans are getting together to build something far less expensive than a PC. He shifted the company's complete strategic movement towards Internet, put it as the highest priority. He also saw this as it's going to change the rule. Internet is something that's going to be something far more powerful than something what IBM created back in 1981. He saw this as a unique opportunity, but also a unique challenge. So let's take a look, the way Bill Gates envisioned Internet fans at that point of time. Are we serverless fans? So hopefully in the next few minutes, I'll be able to explain what the serverless tidal wave looks like, and are we really at that point? So before we get into what serverless is, let's try to understand what are the three core tenets of serverless. The first one, of course, is there is no need to provision servers. Yes, there are servers, but you are not responsible for provisioning, managing, maintaining, operating, administering those servers. There is no need to download, install, or run any software. And that is not just for compute. That is for compute, network, storage, streaming, messaging, emailing. That's all happening for you. That's really the big part of it. And what that gives you is a faster time to market and innovate on a faster clip. The second tenet of serverless is really high availability. At Amazon, we have this concept of a region, which is a physical location around the world, where we cluster data centers. And each group of data center is called as an availability zone. From a serverless perspective, you deploy an application in a region. You don't worry about high availability. It gives you high availability and fault tolerance by default. That's what you're looking for in a serverless application, without worrying about that, am I doing cross-availability zone or what? And last but not the least tenet for serverless is scaling. You can do horizontal scaling very easily without worrying about how many servers have been instantiated. And if you are trying to do horizontal scaling, then you're giving a dial, either CPU or memory, and then accordingly your other assets are allocated to it accordingly. So those are sort of the three core tenets that we look at when we think about serverless as what it is. Of course, there are certain additional benefits to serverless. An important part is when you're building your serverless applications, how easy it is to author and deploy applications. It really allows you to focus on your business logic. Because all I'm doing is, as a Java developer, I'm building my Java applications, and I'm pushing my function logic in the serverless platform. And then I'm not worried about how my deployment is going to happen, how my scaling is going to happen. If my app gets popular, it just scales. It just seamlessly scales. That's really beautiful. And to me, the benefit that I'm most excited about it is, it really forces me to think in terms of best practices for a modern application development. I know the term modern is pretty overloaded, but in this context, we're really talking about what is it that we have learned over the last several years and following those best practices. We know the stateless applications scale much better than stateful, and that's what serverless applications force you to build. We know that the whole drive behind microservices, how it gives you agility, rapid innovation, pace of innovation, and all those functions, all those factors that comes along with it, it really requires you to break your monoliths into smaller functions and have them being triggered using different events. So you're really building an application with a bunch of functions sitting around and then being choreographed to talk to each other. So you're really forced to build a microservices-based application. So those are some of the additional benefits that come as part of building a serverless application. Now, Amazon S3 was the very first service that we launched at AWS. Today, S3 holds trillions of objects, and it regularly peaks at millions of requests per second. So that's sort of the scale at which S3 operates. Now, at AWS, our customers have been the motivation for our innovation. And in turn, we help them with their innovation so that they can increase their pace of delivery as well. So primarily because of listening to our customers, they've been asking us that, OK, you give me a storage capability as part of S3. Give me something that when I store an object in S3, give me a capability to do something around it, or give me a compute capability. Now, that is one of the primary reasons why AWS Lambda was created. Amazon is a customer-obsessed company. 90 to 95% of our roadmap is driven by customers. And so AWS Lambda was announced in 2014 as a result of that. Now, that is not the only reason why Lambda was created. There were hundreds of discussions that were done with our customers, but that is one of the reasons. So just as what we did with compute for EC2 with EC2, the same thing is done for application development with Lambda now. So from your perspective, you don't care about where your servers are provisioned, who's provisioning those servers, how the scaling is happening. Once again, that's the important part of it. So we launched AWS Lambda at re:Invent 2014. And this is sort of one of the snapshots that was captured when Werner announced AWS Lambda. It was really launched with literally 3 services that can trigger an AWS Lambda. And it was at that point called as an event-driven compute. But now let's see how the landscape at AWS has evolved over the last few years. AWS, in that sense, has a very mature and very rich platform for building serverless applications. And I'm not going to go through the complete list over here, but essentially what it gives you is a platform for building your mission-critical applications with a seamless deployment DevOps story. Okay? So let's pick, for example, Amazon API Gateway. Amazon API Gateway is a fully managed service that allows you to create, maintain, secure, and scale your services in a very efficient way. And this is exactly what you use to front-end your business logic sitting in a Lambda function in AWS Lambda. All you have is a REST API. That's what you give to your client. And your customers really talk using that API, and which then triggers the Lambda function at the backend. Now, that's one example. You, of course, need a unified set of developer tools. So one of the tools that I'm super excited about is Cloud9. Cloud9 comes out of an acquisition that we did a couple of years ago. And this is a collaborative editing tool based on a web browser. Once again, as I was talking about serverless tenets, no download, no install, no runtime download to be required. You literally go to a browser in the console, you say, provision me a Cloud9 instance, and voila, you got a collaborative editing tool that you can work with your customers, with the developers in your team, all in the browser itself. It also gives you the debugging capability of your Lambda functions. You can attach a debugger, start looking at breakpoints, and see what's happening really in there. We also have fully managed deployment pipelines. So you can use AWS Code Build or Code Pipeline to do a full end-to-end deployment of your Lambda functions very easily. And last but not the least, you also need some capability. Now my application has lots of Lambda functions that are interacting with each other. I need something to be able to troubleshoot, identify bottlenecks, and do a complete end-to-end tracing as my application is flowing through these Lambda functions. And that's one of the tools that we have called as AWS X-Ray, which is, again, a managed service. And I'll show you some of the ways of how we enable that in a Lambda function. So overall, the serverless landscape has definitely evolved over the last 4 years. It's not just our customers and partners that have benefited from the innovation that has been done as part of AWS Lambda. Now, what I'm showing you here is a snapshot from CNCF, which is Cloud Native Computing Foundation. Now, for those who don't know, Cloud Native Computing Foundation is a vendor-neutral home for some of the most popular projects on GitHub. Kubernetes, Prometheus, Envoy are some of the projects that are hosted by CNCF. CNCF also has working groups, which allows you to work on different technologies. One of the working groups at CNCF is the serverless working group. And it basically looks at the intersection between cloud native and serverless technology. Now, the serverless working group, again, huge props to them, they created a serverless white paper, which basically gives a position what serverless is about, what are the use cases, the definition of serverless. So it's definitely worth a read. And what I'm showing you over here is a broader interactive landscape where they have identified what are the platforms, what are the frameworks, what are the tools that are available as part of the broader landscape. So you can see how the innovation has really grown big over there. Now, one of the players that is worth calling out here is serverless.com, or the company that was started by Austin Collins. This is the company, yes, we pioneered Lambda back in 2014, but soon after, Austin founded this company, and they have done a lot of innovation out in the community, which really allows you to build serverless applications across multiple cloud vendors. With more than 23,000 GitHub stars, this is definitely worth a project to watch out for. So again, shout out to Austin Collins for doing this innovation and continuing to foster the community. Now, Lambda, if you think about it from the AWS perspective, is right in the middle. The different services that are shown around it are the ones that trigger the Lambda function. So think about Lambda as sort of the business logic between different services at AWS. Now, Lambda takes care of more than just your infrastructure. It really allows those services to talk to each other. So let me give you a couple of examples. So on the top right, what you see is Amazon Alexa. So I have an Echo device. I'll have a few Echo devices in my house. Every time my son asks, what time is the Warriors game? There is a Lambda function that is being kicked in the back end that is finding out, talking to the database, and returning the result back. So every time you ask Echo, Alexa, what time is it? There's a Lambda function triggering back. Now, the same mechanism can be used to build your own custom Alexa skill as well. So my older son, who is a sophomore in high school, he built an Alexa skill that we use at our house. Come Friday night, we want to watch a movie, and we'll say, ask IMDb, what is the rating of this movie? And that's a simple Alexa skill he built using Python. He pushed it to Lambda console, and there you go. We got a new Alexa skill. So I would highly encourage you to take a look at it. It's a really simplified development model. If a high schooler can do it, you totally can. Another example that I would like to give over here is how Netflix uses Lambda functions. Now, Netflix is, at a given point of time, depending upon what time of the day it is, 1/3 of the traffic by different reports is running of the internet traffic is on Netflix. Now, Netflix works with a lot of producers. These producers create big content for them. And then now Netflix has to take that content, process it, put metadata into it, and then push it to their CDN. Their process used to take a little bit, but much longer. So what they did is, now they take the content, they break it into 5-minute chunks, they send it out to multiple Lambda functions, the Lambda functions processes it, and then once the results are all connected back, then they take another Lambda function to aggregate the results and push it to CDN. What's the result? Well, it allows them to get the content from their producer and push it to their CDN much faster. Now, yes, that is how we think of it in terms of in the AWS cloud, but that concept very much works for other cloud vendors as well. So pick any cloud vendor. If they have a storage and a database and an API management layer, that would act, that would trigger their corresponding Lambda functions. Now, as the trigger is basically a JSON payload. So I'm storing an object on S3, and that is triggering a Lambda function. But what if, when we think that when we talk to majority of CIOs, they end up picking a single cloud vendor for a variety of reasons. But what if you are in a multi-cloud situation? What if you are storing an object in a S3 equivalent of your cloud, and you want to trigger a Lambda function? Or what if you are storing an object on S3, and you want to trigger a function or a Lambda equivalent on your cloud? Well, today, that is not entirely possible. You have to write a lot of glue code to make that happen. Or there are some third-party products that make it happen. So again, one of the efforts out of the serverless working group that I would like to call out here is cloud events. Go to cloudevents.io. But this is a specification that describes data format in a common way. It really allows the producer and the consumer to be independent of each other. It defines a standard interoperable format by which a producer and a consumer can still talk to each other and can live across cloud vendors. Now, the JSON event, and you can see the different specifications that are over here. And this was announced literally a couple of weeks ago at KubeCon. So this is a very active development work happening in the serverless working group. As you can see, the version is 0.1. So it's a very, very early release at this point of time. And once again, in a very Amazonian way, we'll work with our customers to see how this can be integrated as part of AWS Lambda. Now, let's take a look at it. How can I package and deploy my serverless applications? We believe community is an incredible driver of innovation. So we have created an open source specification, what we call as serverless application model. Now, what it is an open specification. It's basically a YAML file. And in that YAML file, you can define how your application is going to look like. And it's a very template-driven deployment model. It's built on top of CloudFormation. So what you do is you write your YAML file. In the YAML file, you have 3 different resources that have been introduced, which are serverless specific. The first one is a function, which is how your function is going to be called, what your function handler is going to look like, where your code lives. Second is the API. API is sort of which API is going to be the front end for this function. That is your typical use case. And last is a DynamoDB table. So all you say is table, but behind the scenes, just create a DynamoDB table for you. Now, if you think about a classic application, those are sort of the 3 components you need. You need an API, you need a business logic, and you need a backend database. So essentially, the SAM template, as we call it, really allows you to get started with serverless applications rather quickly and easily. And as I said, the model is completely open source. Recently, we also announced the SAM translator, which is open source. Because what happens behind the scenes is you look at the SAM template. From the SAM template, you translate it to CloudFormation, and then that's what is being given back to the AWS cloud to provision all the resources. So the fact that SAM translator is open, it really opens up a lot of possibilities. Now you can start translating into the language of your choice. So let's see what the future brings in that state. Let me show you a simple example of how my SAM template looks like. Now, this is not meant to be readable. I'm going to highlight the certain parts of it. The first one is I'm specifying where my code lives, which is specified by an attribute called as code URI. And in this case, if you realize, I'm specifying the code template to be living on my local machine. That really allows me to debug and test my serverless applications on my local machine. And that's really powerful. Because, yes, my resources are provisioned in the cloud, but I can do the local debugging very easily. For me, particularly, like I spend a lot of time in the flight, I can literally do that debugging from my seat 6A or 22B, depending upon whether I got an upgrade or not. So that's an important part. We talked about AWS X-Ray. And I want a distributed end-to-end tracing for my serverless applications. Enabling X-Ray for serverless application is as simple as just adding this attribute, tracing active. And that's it. And now you have full end-to-end tracing for your serverless applications. And last but not the least, how are we doing canary deployments? Now, I want to introduce a new capability to my Lambda function, or a new business logic to my Lambda function. We have certain pre-built values over here. And the one that I'm choosing the default, which is, say, canary 10%, 5 minutes. What that means is introduce this new Lambda function for 10 minutes, or 10% rather, for 10% of the traffic, and it truly tunes it down to 10%. And if my CloudWatch alarms trigger that, oh, the traffic is not meeting the requirements, or I'm getting more 404 or 503, then fall back. But if the CloudWatch alarms don't trigger, then after 5 minutes, roll over the entire traffic. And there are lots of reasonable defaults depending upon the pace of introduction of canary. So it's really simplified app development and giving you all the capabilities in a declarative way. You also need to share your serverless applications. We talk to our customers. They build their serverless applications, but they couldn't find a way by which these serverless applications could be shared. So we announced serverless application repository at last reInvent. That truly allows you to take your SAM template and push it to a repository over there. And once again, there are a lot of integration points that are available because the SAM template is open, the SAM translator is open. So we're looking at future, what it brings over here for us. Now, we looked at serverless applied primarily to the compute part of it. Let's see how these benefits are applied to other services. We also announced Amazon Aurora serverless. And this is a limited preview at this point of time. But what it is, Aurora is our fastest growing service for Amazon. It is basically a MySQL and PostgreSQL compatible database. And with Aurora serverless, this is typically targeted at variable workloads, where you may not have any workload, and then you get an instant workload, and then the workload kind of vary a bit. So with Aurora serverless, once you configure the database, you don't have to worry about database startup, shutdown. It will automatically scale, and you really pay per the second. So really applying those serverless tenets to database as well. What about containers? We talk about serverless all the time, but the buzzwords that I hear these days are containers. How many of you are using containers today? Yeah, pretty much like 90% of the room. Well, you got to be thinking, I have a Docker container sitting here and sitting there. How do I apply this serverless tenets to container now? Well, at AWS, we have containers in a broad spectrum for cloud journey. So we talk to our customers all the time. So let's see how this concept of serverless is applicable to containers as well. Well, containers, definite advantages over there. They help you make modern applications very easily. You can package your dependencies. It allows you to build, scale, and deploy your applications very easily and effectively, language agnostic, lots of benefits. I'm not going to go into the benefits of containers here. But let's try to understand from an architecture perspective, once you're deploying your containers, how does it look like from the cluster perspective? Well, at the bottom line, you have a control plane and a data plane. What are the roles for those two planes here, essentially? Well, control plane has a cluster manager, because end of the day, data plane is where your containers are running. So it has a lot of EC2 instances running behind the scene. So you need a cluster manager that can manage those EC2 instances. Then you need a scheduler, because you want to run a container. The scheduler should be able to place the container at the right EC2 instance based upon your affinity or anti-affinity. And then you need a controller. So let's say you want to fire up a service, and you want to make sure the service is running constantly. Then the controller will make sure that the service is running. So that's sort of your key components of the control plane. And data plane is where your EC2 instances are running, and that's where your containers are running. So think in terms of control plane and data plane. Those are sort of the two key components here. Let's look at it a little bit more in the details here now. So if we look under the hood, at Amazon, we provide Amazon ECS, which is the service that we announced in, again, 2014, or actually 2015. So that service has been there for over 3 years now. So that gives you the ability to run your containers at scale. And at any given point of time, we have hundreds of millions of containers launched on ECS. And that's per week, by the way. And of course, at last reInvent, we announced EKS, which is Managed Kubernetes Service, which is in limited preview today. If you look a little bit more into the data plane, well, on an EC2 instance, you need to have the operating system. You need to have the Docker agent, or Docker and Kubelet, or whatever your agent is. And that's when your containers are running. Now, at reInvent 2017, we announced Fargate. That's basically applying the way what serverless has done for functions. we're applying the same concept to containers now. So just like Lambda possibility to run functions without provisioning any cluster or managing a cluster or provisioning any instances, you have the same concept available for Fargate. So Fargate is really allowing you to run containers. Just deploy containers. Don't worry about scaling or managing a cluster. That's sort of the key part here. Now, when you're running Lambda functions, yes, there is a data plane. Yes, there is a control plane. But you don't worry about it. You just go to Lambda console. You say, deploy my Lambda function, and you deploy the Lambda function. You want to scale it, it scales. One of the typical customer examples that I like to give here is by FINRA. FINRA is a financial regulated industry, and it is approved by US Congress, actually. It really allows you to, the role of FINRA is to protect customers, or investors rather, and also regulate market. And the way it regulates market is by setting up about 200 plus rules on 3,800 broker-dealers, which then represents 600,000 dealers or brokers across US. So there's a lot of brokers over there. Now, to give you an idea of scale, at any given day, 99% of equities and 65% of options trade goes through FINRA. So they have to apply those rules to make sure there are no inconsistencies in the market. So what that leads to? That leads to running about 500 billion, that's 500 billion validations daily. And what they choose for running that scale? Lambda. And why did they choose Lambda? Well, the reason they chose Lambda is because they were getting average response time, first of all, of 3 minutes, and the peak response time was up to 7 minutes. With AWS Lambda, because it gives them the scalability, they're constantly getting 1 minute response time independent of the volume. And that's the massively parallel computing fabric that the Lambda provides to you. And that's the capability that containers also has in store for you. So if you look at the Amazon Container Services, Amazon ECS and Fargate combination is available today. EKS, which is in limited preview today, we are looking to GA in the next few months. And once EKS is GA, then the EKS and Fargate integration will look at it as well. So let's take a look at it. What can we do? What are some of the challenges when we have to apply these serverless concepts to Kubernetes? Some of the customers, they think about it that, hey, I can bring autoscaler, to a cluster, to a Kubernetes cluster, and then I can apply serverless concepts. Well, what does autoscaler do? Autoscaler takes a look at your health metrics of the cluster, and if need be, it'll provision a new node to the cluster. Or it'll automatically scale your, there's a concept of horizontal pod autoscaler. So not just the cluster, but also the pods will be scaled as well. So that way you can do BYO serverless to K8s. But what are the real challenges, particularly if you're trying to apply true serverless to Kubernetes? Well, think about when you provision a pod, you can give that, OK, I need such and such memory requirements, such and such CPU requirements. Now, with serverless, because you don't care about the concept of a node behind the scene, how do you make that happen? In Kubernetes, again, you can also say, I want an affinity that these two pods should be on the same node, or anti-affinity, that these two pods should be on separate nodes. There is no concept of node in serverless. So how do you apply that concept? We also have the concept of daemon set in Kubernetes, which says, make sure this pod is running on each node of the cluster. Once again, there is no concept of node. How do you make sure that happens? So how do you make sure that logging and metrics, which are typically installed as daemon sets, can be installed and configured correctly? And last but not the least, because you are running a Kubernetes cluster, you have a cost factor involved. You can at least predict your cost that, OK, push comes to shove, I'm running an 8-node cluster, and this is sort of my cost part of it. But when you're running in a serverless mode, yes, it's good to handle your customer traffic load, but then the cost management could become a little bit of a challenging part of it over there. So the point being, yes, there are a lot of challenges for applying serverless to Kubernetes. A lot of discussion needs to be done in the Kubernetes community. And AWS is actively involved in there. These discussions are happening in SIG architecture. Well, the way Kubernetes community operates is there are different SIGs, or special interest groups. So we are involved with SIG architecture, SIG node, And that's where these discussions are happening. Now, let me talk about some of the work that is happening out in the open source for this. Now, Virtual Kubelet is an open source community-driven project that allows you to say that for a Kubernetes can be powered by a pluggable compute resource. And that pluggable compute resource is called as a provider. So this is an open source project. So what we have done at Amazon, we have sent a pull request. Now, this is an open source project, so we sent a pull request which got merged as a Fargate provider. So what that means is now you can take your Kubernetes manifest, run it on Virtual Kubelet, and that will be provisioned on a Fargate provider. Now, remember, this is a very early work. It's just a proof of concept at this point of time. Definitely not for production, because this is not even, there's a lot of steps involved to get this up and running. But this is an area that we are looking at it. Now, this is not the definitive area by any chance. It may become the definitive area, but as I said earlier, there is still a lot of discussion that needs to happen with the community to make sure to see that we are aligned in the correct direction. This is a snapshot of the pull request that we sent, got approved and merged. So we're pretty excited about that. There's a blog on the open source blog which talks about exactly how to get started with this. So as a serverless person, my goal is really, I'm a developer. I just want to build code. I want to focus on my application. I don't want to worry about provisioning, maintaining, scaling, administering, patching servers. I can do that. But it's fun for the first couple of times when I'm learning stuff, but then it becomes very administrative and very boring. So I quickly want to move on to the fun things. So as an application developer, I just want to go build my applications. Thank you.